In this lecture, we're going to do just a few more examples of using the quadratic formula, and we're going to focus on cases where the solution ends up being imaginary. Quadratic formula works just as well in this kind of scenario as it did when the answers came out to real numbers. I just want you to see some examples so you know what this is going to look like. All right, so we're going to start off the same way. We're going to pick up the values of A, B, and C. So A is 1, B is 7, and C is 16. And if we put those into our formula here, this becomes negative 7 plus or minus the square root of 7 squared minus 4 times 1 times 16 over 2 times 1. So under that square root, 7 squared is 49. 4 times 16 is 64. This is all over 2. 49 minus 64, that's negative 15 over 2. And this negative 15, this is negative 7 plus or minus the square root of negative 1 times 15 over 2, which is negative 7 plus or minus I times the square root of 15 over 2. And there's my answer. Like I said a minute ago, the formula works just as well in this case as it did in all the real number situations that we looked at before. All right, so once you try doing this one, right? See if you can't work this out on your own, see what it comes out to. Then start the presentation up again and we'll go through it together. So this one is kind of nice, right? For the A, B, and C, they're all the same. A equals B equals C, and they are all equal to 1. All right, so if I drop these numbers into the formula, I get negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 1 over 2 times 1. We do a little simplifying here. Negative 1 plus or minus the square root of 1 minus 4 over 2, which is negative 1 plus or minus the square root of negative 3 over 2. Whoops, not 3. Square root of that thing over 2. And we get the same thing here, right? We've got a negative number under the square root. So this is negative 1 plus or minus I times the square root of 3 over 2. So here we have a case where there's a fraction. And the quadratic formula doesn't care. You can put fractions in for the A, B, and C. You can put decimals. You can put square roots. You can put any number you like in there, and it'll work just fine. In practice, however, putting fractions into that formula can get a little messy. Here we have A would be equal to 2/3. So you have, that's going to make the 4AC part under the square root of fraction. The B squared part won't be. So now you've got to do a common denominator under the square root and try to simplify, and it's just more trouble than it's worth, right? So I think that when you get a situation like this, it's easier if we take the equation, and well, the first thing I'm going to do is move that 6 over, right? Add 6 to both sides since I know I want this equal to 0. Then I'm going to multiply both sides by 3. That's going to get the fraction out of there. Then I don't have to worry about it. So if I distribute the 3 into the parentheses, this becomes 2x squared plus 9x plus 18 equals 0. Excellent. Now I'm going to go to the formula. Let's see. What do I get? X equals negative 9 plus or minus the square root of 9 squared minus 4 times 2 times 18 all over 2 times 2. And what's going on under that square root? 9 squared is 81. 2 times 4 is 8. 8 times 18 is 144. Right? 18 times 8, 64. Carry the 6. Yeah. Square root over 4. And what happens under the square root? Negative 9 plus or minus 81 minus 144. Let's see, 63, negative 63, right? Square root of negative 63 over 4. And I got to do two things here. Negative 63, that's negative 1 times 9 times 7 over 4. So let's see, negative 9 plus or minus. The square root of 9 is 3. The square root of negative 1 is I. And the square root of 7 stays behind. There you go. There's my answer. So fractions, don't try dealing with them, right? Just multiply through by whatever the denominators are, clear them out, then go to the formula, and it's going to be a whole lot simpler.